So our last session today, we're moving on to acceptance testing, which we're really proud of the fact that that's now got into CP1 2020 as a minimum requirement, having worked on it for a number of years and getting that pioneering the setup for that. And to talk about that, we've got a larger crowd this time. We've got Freddie Valletta, lead engineer at FairHeat. We've got Alan Hassett, a consulting engineer at FairHeat. Ricky Stevens, Operations Director from Orchard Plumbing, and Paul Craig, M&E Site Manager from Telford Homes. Welcome all.
Thank you, Gareth. I'll just go request control now. Has that gone through?
Yep.
There we go. Hi. As Gareth said, we're going to be talking about acceptance testing. First off, we're going to just touch upon the new CP1 2020, as there are some new sections regarding acceptance testing involved in it. Then Ellen and I are going to talk through acceptance testing from both an energy centre and a building level perspective, and then focusing on a dwelling level viewpoint, and then get some perspectives from both the developer and the contractor side as to how their approaches have altered in order to include acceptance testing. Okay, so over to Ellen.
Thanks, Freddie. So heat networks play a key role in the decarbonisation of heat in the UK, and the updated code of practice released earlier this year has been written to improve many aspects of heat network from design through to operation. One of the commissioning objectives in section 5.7 details the requirement for acceptance tests to ensure an efficient and reliable service is delivered. In CP1 2020, there has been a shift in focus to overall network performance rather than performance of individual components during heat network commissioning. So poor commissioning and performance of the energy centre is often associated with unstable flow temperatures. In the past, there's been a tendency during commissioning to solely focus on achieving stable operation during peak load, despite part load conditions being more common during operation. This hindsight leads to unstable flow temperatures during part or varying loads, risking the reliability of the heat network. Poor commissioning and performance of endpoints, such as heat interface units or fan coil units, is often associated with elevated flow rates and return temperatures, where a few poorly performing units can have a detrimental effect on the heat network's performance and efficiency. Acceptance testing provides performance verification of the energy centre and all the endpoints, which Freddie and I will delve into further. Feedback is then provided to contractors for rectification. This process ensures installation, commissioning, and operation are all as per design and performance specification, and prevents issues and faults emerging during the early years of operation, where their rectification would be more expensive and more intrusive. Next slide. So minimum requirements that are outlined in CP1 2020 are as follows. Ensuring the acceptance testing procedure forms part of the construction contract. This is essential as it builds acceptance testing into the development process from day one. Appointing a heat network specialist to carry out on-site acceptance tests. So these acceptance tests are testing the energy centre with a focus on average flow and return temperatures, efficiency, reliability, etc. And then acceptance testing of dwellings, which includes an initial set of tests on a small number of dwellings to establish systemic issues that can be rectified before commissioning and testing the rest of the development. And then taking a graduated risk-based approach to the rest of the development. So that's testing the first 10% of dwellings and then a randomized 10% sample of the remainder. And if any of those fail to meet requirements, then a further 10% should be tested, and so on. So the key outputs here are record sheets a non-acceptance log, and a summary report. On to you, Freddie.
Cool, thank you, Ellen. As Gareth said, we're completely thrilled and proud that acceptance testing has been included within CP1 2020 as a minimum requirement. Although our recommended approach is to take this step one further, and basically our approach is to undertake the CP1 best practice. The best practice outlines that acceptance testing should be carried out over 100% of dwellings and endpoints. And this ensures that correct service levels and design return temperatures can be achieved across the network. This way, the developer and client has the complete confidence that all installation and commissioning issues are addressed and rectified pre-occupation. Whilst you may be thinking that 100% of testing seems a bit overkill and could impact on project timelines, it's actually the best approach to take, not just in terms of the results that it produces, but in terms of being able to budget and plan for this commissioning and testing phase of the works without any unknowns. The 10% plus 10% minimum requirement approach stipulates that if any of those fail, a whole new set of 10% has to be tested and passed in order to prove that correct commissioning. And then another 10% if any fail, another 10% if any of those fail, and so on. This introduces quite a lot of unknowns into project planning and budgeting. It should be said actually that in my 4.5 years of acceptance testing at FairHeat, if we'd have taken this 10% plus 10% approach instead of the 100% approach from the outset, I don't think there would have been a scheme where we didn't actually end up testing 100% of dwellings. Results-wise, this 100% dwelling testing ensures that commissioning issues are not missed. Say, for example, these graphs on the right, this shows return temperatures from 2 phases of a London development. The top graph shows return temperatures from the first phase, which didn't go through any testing at all. And the bottom graph shows the second phase where 100% of those dwellings were acceptance tested. And you can see there's a drastic difference between the return temperatures, showing that performance is actually being met in this phase. In the second graph here, I think Tom Burton actually touched upon this in his presentation earlier. A small percentage of dwellings can actually have a drastic impact on this overall performance. So this graph shows cumulative flow and volume against the number of dwellings. This is a roughly 100 dwelling scheme, and it shows that 10% of the dwellings contribute to 60% of the total flow on a system. So if we underwent acceptance testing on the 10% plus 10%, it's actually very likely that a lot of these poorly performing dwellings would have been missed in this approach, showing, and then therefore would have resulted in high flows and therefore high return temperatures and therefore poorer resident perception of the scheme. This really highlights that remote BMS and heat meter data can also be additionally used to ensure that the heat network is actually operating correctly and performance targets are met outside of this acceptance testing period. So moving on to actually the process of the acceptance testing. This is actually something that we've developed at FairHeat over the last 5 years and 6 years as well. Actually, sorry, 6th birthday event. Acceptance testing, we've come up with this definition which shows that it's rigorous testing to verify your heat network performance, ensuring installation, commissioning, and operation are as per the design and performance specification. Typically, this term has actually been focused on dwelling level tests. However, now it's being introduced as a coverall term applying to performance tests carried out in the energy center and at a building level as well. This process was developed to ensure that all performance issues with individual units and the system as a cohesive unit are addressed, as it's significantly more expensive and disruptive to carry out rectification works post-occupation. As highlighted previously, this is now included in CP1 2020, but it's also in planning to be a market, heat networks are in planning to be a market regulated utility by Q1 of 2023 at the latest, but it could be by the end of 2022. So therefore, many developments currently in planning will fall under this. So it's definitely something that developers and contractors will need to be aware of to factor into their processes. More of that from Ricky and Paul later. So now we'll detail the two types of acceptance testing, starting with the energy center and building level. As I said, the building level, there's been a historic focus on commissioning your individual components separately, with the assumption that the DevOps and control system will tie all of the operation together, with occasional tests proving that the system can actually operate stably at its peak load. However, as heat networks are dynamic systems, the plant equipment needs to be proven to operate under variable and part loads, seeing as these peak loads are rarely seen on systems and only last for a matter of minutes. We'll go through the whole process on the next slide. However, carrying out these load tests on the plant room ensures that design and KPIs are met under these varying loads and ensuring the system operates correctly and as a cohesive unit. So yeah, load testing is able to prove this operation for both phased and whole developments. Once all the plant room equipment is commissioned separately and a sufficient number of endpoints are connected to the network and commissioned correctly as well, the load test can be undertaken. We'd recommend that this is carried out with the sort of BMS engineers and also boiler or heat pump manufacturers on site to ensure that any adjustments can be made there and then based on the performance observed. Load is introduced gradually onto the system, building up to that design peak load. In particular, it will focus on sort of key plant operation modes, i.e. additional boilers or pumps coming on or offline, changeover of heat generation equipment once the thermal store is depleted, for example. This particular focus on sequencing and changeovers ensures that heat delivery is not compromised in these periods of changing load. Return temperatures actually remain low as per design, and your pump differential pressure is maintained across the network. Heat meter data becomes incredibly useful at this stage as flow and demand can be monitored at all points in the system alongside your temperature and pressure data obtained from your BMS. Should say that Sula touched on her presentation the idea of seasonal commissioning. And yes, again, this is when your BMS and heat meter data can be included to fully prove the system performance over a period of time. In practice, these are some of the issues that we've observed on site. As you can see, there's a whole range of issues from heat generation equipment to pumps and the network commissioning, and also the controls as a whole. With an example actually on the right-hand side here, these are two iterative tests over 2 days. And these are secondary flow temperature and return temperature on the secondary side of a sort of district heating plate heat exchanger. In the load test on the first one, once this load was induced, the return temperature was dropping as we would expect as demand was induced on the system. However, the secondary flow temperature also drops drastically as well during this period. And then also, once this load was removed, the plate control caused several fluctuations in that return temperature, as can be seen in the dips in the blue line in the top right-hand corner. Once these issues were investigated and the changes were made, the fluctuation was completely eradicated on a reiteration of the load test, and the secondary flow temperature didn't drop nearly as much as the first time. This was then rectified further on the day to ensure that this secondary flow temperature remained stable and the risk of heat delivery at elevated demand was drastically reduced. This dynamic and iterative testing ensured that these operational issues were again rectified pre-occupation. So I'll hand back over to Ellen, who will then go through acceptance testing from a dwelling side.
So from a dwelling perspective, acceptance testing is designed to focus on 4 key areas throughout the process: heat network efficiency, regulatory compliance, resident comfort, and post-occupancy cost. A set of commissioning parameters and installation benchmarks are set early in the process for commissioning engineers to work towards. Initial acceptance testing is first carried out, ideally as soon as the first 10 to 20 dwellings are commissioned, to prevent the escalation of systemic issues in commissioning. The end user equipment is then tested and checked to verify dwelling performance by inspecting for installation issues and faults, and then carrying out rigorous testing in all 3 modes of operation: standby, domestic hot water, and space heating. Next slide, please. So the process can be simplified to what is seen here. First, we look at installation issues and faults, such as insulation quality. So the final run to HRU accounts for up to 50% of the overall network. And despite this, it's the most common for it to be insulated poorly. So we'll look out for the insulation standard, amongst other faults such as heat meter errors. And we'll look at standby performance, which involves checking heat meter data to see real-time performance. Hot water performance, which includes checking how long residents need to wait for hot water. Space heating performance, such as checking the commissioning of the heating circuits, whether they're radiators, underfloor heating, and ensuring that the heat output required for the room can be achieved. So the correct commissioning of each mode of operation is essential to network performance, as each mode either takes up a large proportion of the total flow or time in any given year, as is shown with the percentages. Next slide. So in practice, a collaborative, structured process has been proven to achieve excellent performance. Major issues can be identified before handover, such as HIU bypasses, radiators plumbed backwards or upside down, electrical issues, and testing 100% of dwellings ensures that all of these issues are addressed. So on the right here are Guru pinpoint graphs showing dwelling and network performance with low return temperatures during each mode of operation, and subsequently low return temperatures on the network. Guru Pinpoint has proven to be an incredibly useful tool in visualizing this dwelling and network performance throughout the acceptance testing period, and also in ongoing performance analysis.
Thank you, Ellen. We've actually seen over the years that this process has myriad benefits, not just for one particular party of each project, but for all major stakeholders, like developers, designers, contractors, and ultimately the end users, the residents. This shows acceptance testing's real value and justifies its inclusion in CP1 2020. I'll now pass over to Ricky and Paul, who'll hopefully back me up and confirm some of these benefits, and they'll touch on this further in the next section. So first up, Ricky is Operations Director at Orchard Plumbing.
Hi there, Freddie, thank you. Yeah, in our experience with acceptance testing as a whole, going back 4 or 5 years ago, before we came across FairHeat, there was very little done in the actual dwellings. A lot of the concentration and witnessing was actually carried out within the energy centres itself, with all the time associated in that area. When we first came across FairHeat and the acceptance testing over at Chelmsford, we had large reports come back with a number of areas failing. At the time, we had to adapt quite quickly to changing the ways we commissioned, setting up the plots. The difficulties we initially had were with the plumbers, with lack of understanding and wanting to understand. But soon, with FairHeat and talking with them, looking at upskilling our workforce, having the correct equipment, and obviously working through the correct process from the onset, it worked a lot better. After you obviously initially set up and go through this process, we can have the reliability of, once we actually hand over the plots, that we have very little defects, and we have the we actually have the peace of mind knowing that we are going to have a system that is set up correctly, and the peace of mind also that when we do get calls, we know that it is not due to the design or the actual process we have followed throughout the commissioning and witnessing. From a contractor point of view, what we have also done, we have built in our own developer managers that will help with the witnessing ourselves. So if we are struggling, or our team are struggling, to have a direct point of contact on site. And we have now followed this up on all of our projects for ease, just to keep in the same processes going throughout. I think that's about it, Freddie, from our point of view.
Hi, thank you very much, Ricky. I couldn't find my unmute button then. Thank you. Now moving on to developer's perspective with Paul Craig, M&E site manager at Telford Homes. Hopefully he's still on. Gareth, can you see Paul on the attendees list? I know he had some internet issues earlier.
I can see Paul, but I can't hear him.
Paul, are you there? John, do you want to jump in? Paul, can you hear us? Are you're muted? There we go.
Can jump in if Paul's having trouble.
Yeah, might need you to, John.
Yeah, okay. Totally unprepared for this little section, but yeah, that's all right. At Telford Homes, we have installed the process of 100% flat testing, as Freddie has said. It has proved vital across all our developments. And if we were just having the CP1 recommended 10% plus 10%, a lot of the little details that we are picking up in the very detailed sort of snagging process would probably be missed and would slip through. As you probably picked up on some of the other discussions throughout the day, it only needs a small amount of bypass on an HRU for the network to go down, and otherwise all the commissioning within the flat it's picking up loads of little details which collectively, individually may be quite small, but they do all have a knock-on effect to the wider network. Yes, it is a time-consuming exercise, and yes, it happens at a fairly critical time, normally in hopefully in the weeks before handover, not the day before. If it's managed correctly and we build the time into our programs, any errors and discrepancies which we do find, and we all live in a real world, there are glitches here and there. We're finding that they are all getting swept up in the comprehensive sign-off process related to all the acceptance testing. So yes, it's time consuming. Yes, there is a cost associated with it, but our after-sales department are basically handed over a flat that is snag-free, fully operational, tied up with a red bow around it, and everyone is happy. Hopefully that was basically what Paul was going to say.
That's great. Thank you very much.
Cool. Thank you. Thank you, John. Excellent. Yes, that's both developer and contractor perspectives. So I'd like to invite, if anyone's got any questions, to whack them in the Q&A box.
Yeah, so the first question that came through is, from a developer's perspective, do you find it difficult factoring in acceptance testing into the project timeline, especially as it would be occurring into the immediate run-up to handover? I think, John, that's coming back to the point you made. It is coming in at quite a difficult time.
It is, yeah, but because we've been rolling out acceptance testing on a number of projects recently, we know it's there, we know it's coming. It's not like we wait till we've got 300 flats all sitting there and then acceptance test them all at once. As soon as we've got flats ready, there's a rollout process. We do, as Freddie mentioned, we do a sample of 10 or 12 flats as soon as they're ready to debug those. So if there are any errors, they're picked up early and are rolled out. So in theory, it's a tick box exercise, but it's a very important tick box exercise that catches any errors.
Thanks for that. The second question, is 100% testing necessary? Surely that's a huge cost/time commitment. Actually, yes, Ricky, what's your view on that?
It is a huge cost, like initially, but like I said before, is once we know the units are handed over, we know there's no issues with them properties, and it does highlight issues during that process. So rather than coming back on a defect that could have been resolved at an early stage when we've got people on site, it does help it in the end. Generally, as long as you have the set parameters set up from the onset, and you go through like Freddie has highlighted and Ellen, that you pick up all the initial problems, you don't then generally get that moving forward. And after the first 10%, it is a lot quicker.
John, do you have any view on that?
Yeah, only that say if we don't do 100%, it could be the 99th flat that's got a problem on it, which bypasses the HIU or something, and we're back to square one on the heat network. And plus, as Ricky was saying, if we've got problems on the site with errors in the flats, it's 10 times harder to rectify those once we've got a disgruntled tenant sitting there than if we can iron it all out before handover.
Yeah, definitely.
So, Freddie, you're leaping in? Yeah,
I'll just add to that. In addition to sort of the making sure that everything's picked up, in regards to sort of the time impact of it, this is where it comes back to process. I mean, if you kind of dive into this thinking it's going to be an easy procedure just to sort of go in, sign off a flat, then you need to sort of have a real think about it, because we've got the acceptance testing sort of procedure to a stage where it is, with all of these sort of gateways and processes in place to ensure that everything is as clear as possible between all parties, say the developers, ourselves, the contractors, and also with assistance from the designers as well, to ensure that everyone knows exactly what they're doing at all stages, to make sure that the process actually just runs as smooth as possible. And as Ricky said, the first visit, ensuring there's maximum sort of clarity and collaboration between ourselves and the contractors, lots of site present, ensures that any queries that they have and any sort of systemic issues can be picked up as soon as possible and then not rolled out towards the rest of the site.
Thanks for that. Another question that's come through. How long does a 100% acceptance testing typically take? Are we talking 2 to 3 weeks or a month? Any thoughts on this?
It's not that long. Oh, hang on. So guys, can you hear me now?
Oh yeah, we can. Brilliant.
I'll come back. Bloody hell, I don't know what was going on with that. So yeah, I mean, from experience, the acceptance testing doesn't take too long at all. We normally get around 20 plots a day. Is that right, guys? Assuming we go through the correct procedures, we go through our QAs, we get everything in place beforehand, and we've achieved the desired standard as per the benchmark visits. Sorry about that previously. I don't quite know what was going on.
That's okay. No worries.
Yeah, sort of reiterate that. Depends really on just how large the scheme is, and how quickly sort of commissioning can occur at a dwelling level. Acceptance testing can really just follow that up straight away in order to verify that the commissioning and installation has been done correctly. And as Paul says, you can, with a single person, you can sort of cover about 20 in a day. So it's really just based on how quickly the scheme can be built and commissioned, really.
Yeah, for me, the time is actually in checking it before the likes of FairHeat would come out. That's where we lose, where we spend the time, obviously, making sure things are correct before that day.
Yeah, definitely. As Ricky says, when we go through our internal QA as we've adopted the acceptance testing procedure as part of our standard procedures now, we spend a lot of time pre-acceptance testing, making sure they're ready, making sure the insulation's intact, making sure everything's as per design, so we can fast track this acceptance testing process and maintain 100% plots in line with our program and well ahead of handover.
And I think that actually is the joy of acceptance testing, because we're actually getting, I think we're now seeing the systems that are coming through and the performance we're coming through and the customer impact as a result of that process going through actually being much higher. This question from Dominic Latham. Is a guru system or similar important for finding issues in the network / HIUs? John, you're nodding away.
Yeah, definitely. With although it's primarily a metering and billing system, the pinpoint software that supports it is a great diagnostic tool, so we can monitor systems. And if we've got an HIU that's going to fault for any reason, rather than trying to hunt through 300 flats to work out which one it is, we can pick out straight away and go and knock on Mrs. Jones's door, or the door next to her in the corridor, hopefully in future projects, and resolve the fault.
Ellen?
Sorry, we had an anecdotal one of our projects a little while ago where there was a shower had been left running for about a month. We thought it was our fault having left it running from a load test. Completely wrecked the bathroom, which all had to be refitted out. But the pinpoint demonstrated that actually the shower was turned on 2 weeks after we'd handed over the keys to the flat, and it was actually the owner-operator who'd left it running. Their concierge had been having a cheeky shower, and we told them that they would turn the shower on at 4 o'clock on a certain day, and we had the computer evidence to prove it. So it's a very good diagnostic tool for many reasons.
Yeah, I think it helps especially to find those like last few flats that are poorly performing. You know, that graph that Freddie showed with the 10% of flats taking up the majority of flow. It can really help that further along if a HIU starts bypassing or is in any sort of fault mode. We can catch that by just looking on Guru Pinpoint. So it's great for ongoing performance analysis.
Yeah, I think data is really important. And I think that's been a theme coming through. We need that. I think it's really important as well to close the loop. Thank you very much. That's all the time we've got. Thank you very much for coming on today.